Hello and welcome. Today, we're going to talk about variable air volume boxes, or VAV boxes, with a special focus on how they're used in New York City School Construction Authority projects. If you're new to the subject, don't worry, we'll start from the basics. You'll learn what a VAV box is, why it matters in school buildings, and the specific standards and requirements the SCA puts in place to make sure students and teachers have a comfortable, healthy, and efficient environment. So let's get started and dive into the world of VAV boxes for SCA projects. A variable air volume box, or VAV box, is a small but very important part of the HVAC system in a school. Think of it as a traffic controller for the air that comes from the air handling unit. Instead of always blasting the same amount of air, the VAV box adjusts how much air is delivered to a zone, based on what's actually needed for comfort. Here's how it works. Air comes from the main air handler through the ductwork and enters the VAV box. Inside the box, there's a damper, basically a movable blade, that opens or closes to regulate airflow. If the classroom only needs a little cooling, the damper partly closes and reduces the air. If the room warms up and needs more cooling, the damper opens wider to let more air through. Many VAV boxes in SCA projects also have a reheat coil, usually with hot water. When the classroom is too cool, that coil warms the supply air before it enters the space. This way, the system can both cool and heat the classroom as needed. The brains of the unit is the BACnet controller mounted on the outside of the box. This controller takes input from sensors, like the room temperature sensor, the carbon dioxide sensor for demand-controlled ventilation, and the velocity sensor that measures airflow. It constantly makes small adjustments to keep the classroom comfortable while saving energy. From the building management system, operators can monitor every VAV box. They can see alarms, adjust settings, and confirm that the box is delivering the right airflow and temperature. Key requirements in SCA projects. Now, let's talk about what the School Construction Authority requires. VAV boxes have to be factory assembled and certified. They come with BACnet digital controllers and velocity sensors so they can hold airflow steady no matter what the duct pressure is. Controllers are mounted outside the box to make service easier. The box itself is built from galvanized steel with insulation and acoustic lining, and the damper must have very low leakage. Controls must use native BACnet, not proprietary gateways, and they need to tie directly into the school's automation system for alarms and monitoring. Many boxes also come with hot water reheat coils, which kick in during cold weather to add heat at the classroom level. And finally, the adhesives and sealants used in these boxes must meet indoor air quality standards set by SCA QMD and LEED. Control strategy. Here's how the control sequence plays out. The VAV box reads signals from a room temperature sensor, a carbon dioxide sensor, and its own airflow sensor. Based on that input, the controller moves the damper to modulate airflow. If the room needs heating, the hot water or electric reheat coil opens up to warm the supply air. If carbon dioxide levels rise, meaning more students are in the room, the box increases the minimum airflow to bring in more fresh air. And the whole system runs on a schedule, switching between occupied and unoccupied modes automatically. Scheduling and acoustic limits. Each VAV box is detailed in the project schedule. That schedule shows the inlet size, the airflow range, static pressure, weight, and the sound rating. Classrooms need a quiet environment, so boxes can't exceed NC 35 under normal conditions. The schedule also records which manufacturer and model is used, and it ensures the units are placed in spots that are accessible for maintenance without disrupting class. For demand-controlled ventilation, minimum airflow values are set for both occupied and vacant conditions, so the system balances air quality with energy savings. Commissioning and testing. Once the boxes are installed, contractors must test them carefully. Ducts and boxes are checked for air leakage. Every box has to pass a functional performance test, which is signed off by a factory-authorized representative. Finally, custodial staff receive at least 8 hours of training so they know how to start up, shut down, troubleshoot, and maintain the equipment. Fan-powered boxes, FPB, include a small fan and can be either parallel or series. Parallel FPBs have the fan placed outside the primary airflow, pulling warmer air from the plenum, typically running during heating or deadband modes. Series FPBs have the fan in line with the primary airflow, usually running continuously to deliver air to the space, allowing for downsizing of the central unit. So in the context of SCA projects, a VAV box isn't just a damper. It's a smart terminal unit with its own BACnet controls, tested materials, sound limits, and demand-controlled ventilation features. Each one plays a role in giving classrooms precise airflow, proper heating, and good air quality, while tying into the school's central automation system.